High-intensity movement analysis must be considered best practice in sports injury assessment and rehabilitation, as low-intensity control does not give adequate insight into the cause of injuries and how to manage them. Performance and musculoskeletal health is dependent on how physical components interact. That interaction, in turn, is based on the constraints each component has and how those constraints interact. In low-intensity movement, that interaction is different from the interaction at high intensity. There is no gradual transition between the interactions from low to high intensity. The transition is sudden and dramatic, a so-called phase transition. Phase transitions are the biggest problem for transference of training to sporting performance and for the assessment of an athlete. Even when the postures in low and high intensity actions resemble each other, there can be phase transitions between the two modes that mean there is no common specificity. Analysing low-intensity control does not give insight into the high-intensity self-organisation of the organism. Internal force landscapes can be completely different between the two postures, and the stress on the body can differ substantially. In high-intensity running, movement is constructed from the bottom up, from small to big. Muscle-tendon interactions stabilise contraction modes. For instance, Achilles tendon and soleus fibres balance each other into a stable ankle action. Muscles influence each other via shared aponeuroses, and shear forces are mitigated by force sharing. Shared forces direct and optimize energy transport, whilst pelvic control provides the launch platform for this energy transport. With this understanding of anatomical constraints as a foundation, movement can be analysed in such a way that performance limitation and injury risk can be accurately identified. For instance, in the running pattern of this player, with a long history of hamstring injuries, we can analyse where self-organisation fails and shear forces travel through the body, resulting in regular recurrence of hamstring strains. A key to self-organisation in high-speed running is good build-up of self-protecting tension of leg muscles during late swing phase, with precise timing that results in optimal tension just prior to initial contact. After toe-off, the hip does not flex instantaneously and the knee stays behind too long. There can be a number of reasons for this. One can be a misconception about the push-off. Too much effort and prolonged force application, like with this athlete, will put the stance leg in a position that will make swing leg recovery difficult. As a result of a long push-off and of the round pendulum, there is sudden forward collapse of the pelvis at toe-off. Forward tilt of the pelvis around toe-off makes elastic loading of the hamstring difficult. When the lower leg travels out, the hamstring is stretched at the moment it becomes active. This hamstring stretch will be compromised by the inevitable backward rotation of the pelvis, needed to correct the forward collapse. A shockwave goes through the hamstring and it cannot function the right way. From such analysis, recommendations can be drawn for training and injury prevention, especially the changes in running technique that will be pivotal in how successful the training can be. Understanding the pelvis as the launch platform for self-organisation from proximal to distal will help to understand the mechanisms behind the occurrence of soft tissue injuries in sports, and is the first step toward eliminating them. Individualisation of training is the next step in developing professionalism in sports. Movement analysis should be the foundation for individualisation. Understanding running, how exercises transfer to competition, and how movement patterns are constructed in open situations is essential for this analysis.